Hey, what's up, guys? Today, let's look at the Lintcode problem number 31, partition array. Let's see what this problem about. Given a array nums of integers and a int k, and we need to partition this array and partition such that all the elements less than k are moved to the left, and all the elements great equals to k are moved to the right. We need to return the partitioning index. The first index, I should be nums I great equals to k. Let's take a look at this example. If the nums equals to 3, 2, 2, 1, and the k equals to 2, and the valid answer is 1, because the answer is obvious. So 1 is the partition index. So how do we do this? How do we approach this algorithm? And first, we need to know that this is a partition array type of questions. And second, when it comes to a partition array, we always have to come up with the solution that 2 pointers is kind of like a reflection. With time goes on, you will get more and more familiar with this 2 pointers solution. Array 2 pointers always link together. So let's see how do we do it. So we're going to use 2 pointers. Let's directly walk through the code. Partition array is the entrance. We take 2 parameters. One is the numbers. The other one is the k. So first part, we always check the parameters. If the numbers is an empty array, or the k less than 0, so we just return 0. Return the default partition index. You can return -1. Return value. You need to talk with your interviewer if he is okay with that. So then let's come to this core part. We started doing this partitioning. By using partition strategy, we need to define 2 pointers. One is the leftmost pointer, we call it start. The other one is the rightmost pointer, we call it the end. The leftmost pointer, we start its index to be 0. The rightmost pointer, we initialize its value to be the last elements of the array. Then we use the while loop to resolve this whole algorithm. This is the core part. So what does this while loop do? And first, we need to know that the outside while is control when do we need to stop this internal process. So when the start, great, then end pointer, then we can stop this whole while loop thing. So inside, let's see what does this while loop do. The while loop actually do 3 main logic. One is the first while loop part, but it's still a while loop. And the second while loop part, and the third one. Third one actually is the swap. Let's see what does this guy do. While start less equals to end, and numbers start less than k. So we just increase start by 1. What does this mean? Because by the question description, the requirement is that the left part of the array need to be always less than k. So start actually stands for the left part of the array. If the numbers start less than k, that means this element is the qualified element, so we leave it alone. We continue to scan the next. So when this while loop exit, so what does it mean? That means we found the first element that does not satisfy this condition on the array left, and we mark it with start index. And same thing, the second while loop is for detecting the right side of the elements, which one is not satisfy the condition, because on the right side, all the elements has to be great equals to k. If the while exits the end, pointer point to the elements that does not satisfy this position, this condition. So since we found two elements, and left elements and the right elements, so we're going to just do a swap. If we swap, then we will make this condition satisfy. But before we do swap, we need to make it a efficient swap, because we assume that the swap, the cost is really high. So we need to check if the start less than end, that means start and end, they point to the different elements, then we're going to just swap them. After we swap them, and start and end, the elements will be qualified. So we just continue moving on. We increase start by 1 and decrease element decrease end point by 1. And then we go back to the very beginning, go to the outside while loop conditions. If start continues, less than equals to end, we continue this process. We're going to just found one element does not satisfy the condition on the left, and found one does not satisfy the condition on the right, and then we swap them until reaches to this condition. And in the end, the partition and index, what we're looking for is this start. So we just return the start and problem result. Several things to be careful. The first is this boundary issue. When to stop the outside while loop. So the condition is start less equals to end. And second, when to stop the first, inside this while loop, when to start this while loop, when to stop. It has to be start less than equals to end. Remember, there is a end. And same thing for second while loop. We also have to put a equal sign here. And when we do the swap, we don't need the equal sign. So generally speaking, 3 while loop is the template. And we need to put equal sign for each while loop. So that's the key. Alright, so let's run this algorithm. Looks great, so it worked. So thanks, that's today's algorithm. Thanks if you like it, and please subscribe. Thanks.